So at this point, we're going to go ahead and find out a little bit about what dynamic memory allocation is. All the local variables that we've been declaring, they are placed on the stack, and of course anything that's created on the stack is going to be cleaned up for us automatically, which means that when it hits the ending block of where it was declared, it is automatically cleaned up. The same thing is not true with memory that is created on the heap. We actually take charge of cleaning up any memory that we create on the heap. So let's take a look at this example. I have a variable here, b, that is able to go and hold the address of an int. So there it is. But you will notice that I don't actually have an int that I can point to. So where do I get that int? Well, I go ahead and use this function called malloc, which is going to go ahead and allocate this place in memory that has the ability to store an int. So there is this place in memory, and it has the ability to go and store an int. So there it is. Now you will notice that this place that we've actually allocated in memory doesn't have a name associated with it. This one has a name. We can go ahead and say, alright, there's the variable b, but this one does not. So what we need to do at this point is immediately connect it so that we have some way of getting access to this memory that is being defined on the heap. So there it is. We go ahead and use malloc to create the memory, to store an int, and malloc is going to go ahead and return a void pointer. Now we need to actually go ahead and do this casting to make sure that both the left side and the right side are compatible. B can only hold the address of an int, and so malloc, which is returning a void pointer, needs to also be casted to be able to go ahead and assign this address to this location, and so everything is compatible on both sides. Then we are able to go ahead and use the notation for pointers just like before, which is saying here we have b. Let's go ahead and do a jump, which lands us right there, and put a 30 right there. And then finally, when we're done, we want to go ahead and get rid of the space by using free, so free b. So whatever this is connected to, it's eliminated for us. Now malloc is the C function. There's also the C++ notation that we can use. New int. Notice there's no casting that's needed. It's automatically going to be done for us. And then when we're done, we go ahead and use the delete keyword instead. So new and delete go together just as malloc and free go together. Let's go ahead and take a look at another example. Here, what we want to do is we are wanting to go ahead and create, in a sense, an array. But you notice something interesting about the array. This array that we have created basically is comprised of a pointer variable, and then we have this area in memory that we have created on the heap. And this is not like a normal array. In a sense, we have put the array together. So let's see how this is done. What we do is we're saying that we have a variable which is sitting on the stack, which has the ability to store the address of a char. So we can put the address of a char there. Then we're going to go ahead and ask the user, well, how many elements do you want in this array? So the user says, 3 or 4. So in this case, that would be 4. So A now will contain a 4. And now what I'm going to do is I'm going to go ahead and use malloc. So there it is, malloc, to go ahead and we say size of char, which is 1 byte. And then this asterisk is saying multiply by 4. So 1 times 4 is 4 bytes. So we have 1, 2, 3, 4 bytes. And this is an array of chars, and we're going to go ahead and cast it to indicate that we are returning the beginning address of this char. So this is the address of a char, and that's going to go ahead and land right there. So B is now going to go ahead and point to it. So then we actually have this visual right here. And this begins to look like a normal array. Except that if you remember with arrays, when we go ahead and declare a normal array, all of this is actually created for us automatically in the declaration. Now we actually had to create this, and then we had to create this. And of course, this is all, it doesn't have a name associated with it, which is the reason why we need to go ahead and connect these two entities together immediately, which is what's being done here. And once we've done that, then we can actually go and just use it like a normal array. We are saying, why don't we go ahead and copy Joe into B, so Joe is going to go there. We'll have a null at the end, B sub 0, so B sub 0 is going to be right there. We're going to go ahead and replace that J with a D, so that's going to be Doe. And then once again, we do a free B So whatever this is connected to is going to be eliminated, so it's going to be erased. We could do the exact same thing using the C++ syntax, so we can say use the new keyword and then char, which is the elements that we're going to be storing, and then this is the array notation to say that we want to go ahead and allocate the size of a 4-element array. No casting is needed, and then we assign it to B just like before. All of this other notation is the same. Now the only thing that's different is that when we want to go ahead and eliminate the stuff on the heap, we have to use once again delete, but notice that we actually go ahead and use the brackets right before the B variable, and the reason is because this is an array. To continue on with this, let's just go with one other final example. Let's just say that we want to go ahead and use malloc to also go ahead and create this structure on the fly. So f right now is going to be a variable that's going to be able to go ahead and point to a structure, but notice I don't actually have a structure to point to. I use malloc and I go ahead and say, oh, now I have an entire structure that I can point to, and I'm going to go ahead and cast it, and so f now has the ability to go ahead and point to this area in memory that's able to go ahead and hold the structure. And of course, being that this is a pointer variable, I'm going to go ahead and use the parentheses and the dot notation, and then grab a hold of the various members to go ahead and assign values to it, as we've discussed in the previous structure notation. And once again, when we're done, we'll need to go ahead and get rid of the space on the heap, and we go ahead and use the free keyword. So this is just a very quick synopsis of being able to go ahead and allocate memory on the heap.